Hello friends, welcome back to my channel. In this video, we are going to discuss MCQs on Physical Pharmaceutics 2, Unit 1, Colloidal dispersion. So let's begin. Dispersion is a dash system having one phase dispersed in another phase. So the answer is heterogeneous. The next question is, if the dispersed phase is a dash, dash or dash in the dispersion medium, the system is termed as foam, suspension or emulsion respectively. So the answer is gas, solid and liquid. The next question is, dash dispersion system behaves as true solutions where the solute phase is present in the solvent phase. The answer is molecular. The next question is, in molecular dispersion system, the dispersed phase is homogeneously distributed as separate molecule or size below dash throughout the dispersion medium 1 nm. The next question is, colloids are micro-sized heterogeneous dispersed system with dispersed phase particles ranging within 1 to 1000 nm. The next question is, separation of colloidal dispersed phase from dispersion medium is brought about by microfiltration. The next question is, milk is the emulsion of fat and other substances in water. This is an example of dash dispersion system. The answer is colloidal. The next question is, coarse dispersion is a heterogeneous dispersed system having dispersed phase particles greater than 1000 nanometer. The next question is, in coarse dispersion system, the dispersed phase separation from continuous phase is easily through filtration. Suspensions and RBCs are examples of coarse dispersion. The next question is, if the particles remain dispersed in the solution and do not settle down or mix, it is called a colloidal dispersion. The next question is, dispersed phase can be defined as the substance dispersed in the solution, while dash can be dispersed as solution in which the substance is dispersed. And the answer is dispersion medium. The next question is, the dash system consists of a uniformly distributed dispersed phase in dispersion medium. The answer is colloidal. When observed under a normal microscope or through naked eyes, appear to be dashed because the particles are not visible. Homogeneous. The next question is, when a colloidal solution is observed under the ultramicroscope, it appears to be a dash dispersion having two immiscible phases as colloidal particles reflect the light rays. The answer is heterogeneous. The next question is, the dash in a colloidal dispersion depends on the preparation methods and particle affinity to the dispersion medium. The answer is particle shape. The next question is, dash is influenced by the shape of colloidal particles. The answer is dispersion color. The next question is, the size of the dispersed colloidal particles ranges from 1 to 100 nm. Colloidal dispersion with dash as dispersed phase and dash as dispersion medium. The answer is gas and solid. The next question is, froth and whipped cream is a colloidal dispersion with dash as dispersed phase and dash as dispersion medium. The answer is gas and liquid. The next question is, jellies and cheese is a colloidal dispersion with dash as dispersed phase and dispersion medium. The answer is liquid and solid. The next question is, colloidal systems present in fluid state and made up of two or more components is known as salt. The next question is, a surfactant solution above the critical missile concentration, an aerosol and an emulsifier are example of salt. The next question is, dash are colloidal solutions in which the dispersed phase particles have great affinity for dispersion medium. The answer is lyophilic colloids. The next question is, dash colloidal systems are quite stable as the dispersed phase does not precipitate out easily. The answer is lyophilic. The next question is, in dash colloidal systems, if the dispersed phase and dispersed medium get separated from each other, they can be reconstituted by mixing the solution. The answer is lyophilic. The next question is, an example of solvent-loving colloids are polymers in organic solvents. Dash colloids, the dispersed phase and dispersion medium particles in colloid solution do not have any affinity towards each other. The answer is lyophobic. The next question is dash colloidal systems are not stable as they are easily precipitated by adding small amount of electrolytes by simply heating or by shaking. The answer is lyophobic. The next question is the reconstruction of dash colloids is difficult because after getting precipitated they do not regain their original state even when shaken with dispersion medium. The answer is lyophobic. The next question is an example of solvent heating colloid is colloids of metal. The next question is dash colloids are stable and show similarity with true solutions in many aspects. The answer is macromolecular. Question is starch, cellulose, proteins and enzymes are examples of naturally occurring macromolecules. The next question is which of these are man-made macromolecules? The answer is polythene, polystyrene, nylon. So all of the above. The next question is in dash colloids on dissolving any substance, large number of small molecules combine to form species having colloidal size ranging between 1 to 1000 nm. It is multimolecular. The next question is a gold salt containing particles of varying sizes consisting of several examples is an example of multimolecular colloid. Next question is some substances behave as a colloidal system as the particles undergo aggregation. These aggregated particles are known as macromolecules. The next question is temperature above which micells are formed is known as craft temperature. The next question is soaps and synthetic detergents are example of associated colloids. The next question is lyophilic colloids are precipitated by high concentration of electrolytes. The next question is the scattering of light by colloidal particles is known as Tyndall effect. The next question is when strong beam of light is passed through a colloidal solution in a duct surrounding the beam path got illuminated forming a Tyndall cone. The next question is dash do not show Tyndall effect because the solute molecules or ions are so small that they do not show scattering of light. The answer is true solutions. The next question is the source of radiation in light microscopy is visible light. The next question is the particles of size range less than dash appear as single blur under light microscope. The answer is 0.2 micrometer. Dark field microscopy, a colloidal dispersion contained in a cell is observed through dash against a dark background at right angle to an intense beam of incident light. The answer is ultramicroscope. The next question is ultramicroscope is used in microelectrophoresis is technique for measurement of particle charge. The next question is dash help in the study of size, shape and structure of colloidal particles. The answer is electron microscope. The next question is smaller is the distance between two objects, greater is the dash of an electron microscope if radiation of smaller wavelength is used. The answer is resolving power. The equation gives the dash of colloidal dispersion. The answer is turbidity. The next question is the equation gives the dash of the colloidal particles. The answer is molecular weight. Measured by two instruments, dash and nephelometer. The answer is spectrophotometer. The next question is dash measures the transmitted light intensity in the direction of incident light. The answer is spectrophotometer. The next question is using dash scattered light intensity is measured at right angles to the direction of incident light when the amount of particles dispersed in the solution is low. The answer is nephelometer. Dispersion is visible only when the size of the particle is reduced to 2 micrometer. The next question is increase in dispersity of colloidal particles leads to a significant decrease in their sedimentation. The next question is viscosity of a colloid dispersion is affected by shape of the dispersed particle, affinity of particles to the medium, molecular weight of the particles, that is all of the above. The next question is FeOH whole thrice, COH whole thrice, aluminium hydroxide, calcium hydroxide, TiO2, methylene blue and hemoglobin are examples of positively charged colloids. The next question is potential present at the solid surface is the dash, which is the difference in potential between the actual surface and the electroneutral region of the solution? The answer is electrothermodynamic potential. The next question is potential present at the surface of solvating layer is the dash, which is the difference in potential between the surface of the tightly bound layers of the electroneutral region of the solution. The answer is zeta potential. The next question is dash is the process in which the charged particles move through a liquid under the effect of an applied potential difference. The answer is electrophoresis. The equation represents Donan membrane equilibrium. In the method, the atomic or molecular size of particles are combined to form colloidal aggregates of specific dimension. The answer is condensation. The next question is in dash method, bigger particles of substance in the presence of dispersion medium are broken down into smaller ones to form colloidal particles. The answer is dispersion. The next question is dash involves milling and grinding of coarse suspension of a substance in a ball mill, colloid mill, or ultrasonic disintegrator. The answer is mechanical dispersion. The next question is dash is used for preparing solutions of different metals like silver, gold, platinum. The answer is Burdicks arc method. The next question is in dash method, a freshly prepared PPT is converted into a colloidal solution by shaking it with the dispersion medium in presence of small quantity of electrolyte. The answer is peptization. The next question is through dash the macromolecular impurities can be separated from the colloidal dispersion based on the difference in diffusion rate through the membrane. The answer is dialysis. The next question is the dash of lyophilic colloids decrease when small quantities of electrolytes are added to the salt. The answer is zeta potential. The next question is when lyophilic colloids are mixed with oppositely charged colloidal particles, dash occurs. The answer is flocculation. The next question is a decrease in dash can be observed when electrolytes are present in great amounts in lyophobic colloids. The answer is interparticle repulsion. The factors responsible for stability of colloidal dispersion are solvent sheet around each particle, charge on the particle. So both A and B. The next question is when solvent having a higher affinity for water are added to dispersion medium, the dash coagulation of colloidal particle occur. Answer is coagulation of the colloidal particles occur. The next question is in dash process when hydrophilic colloids having opposite charges are mixed together, a layer rich in colloidal aggregate is formed due to separation of particles from the dispersion medium. The answer is coacervation. The next question is a colloid. A dash colloid is a colloid which helps in stabilizing other colloid. The answer is protective. The last question is smaller the dash of a protective colloid, greater will the protective power of the lyophilic colloid. The answer is gold number. For now, thank you.